Oh, oh shit. What is this? This is, okay. Well, let's try to do something about this. Well, notice that we have a negative x here and a negative x here. Okay, maybe we might be able to factor that out. Okay, so we have like e to the x, ex, or sorry, xe, xe, and then whatever. It continues on. And then here we have e to the negative x, e to the x. And we factored out negative x, so e to the negative x dx. Okay. Huh. Let's let u, we're just experimenting, right? Let's let u equal negative, e to the negative x. Okay. Then what would happen is we will get, see, we get 0 here, we get 1. Like infinity here, we get 0. Oh, okay. And then the du has the negative, we can utilize this negative to turn this bound around. Okay. So then we get from 0 to 1, and then let's see, how do we write this? So before we write that, how would we write this in terms of u? We have e to the negative x, e to the negative x, right, and then e to the negative. Okay, so I think we have a clear equational visual thing where this is just u to the u to the u tetration infinitely. Okay, we just wanted to see that and make sure. Okay, so then in that case, so we do have an integral from 0 to 1, and we do have u to the power of u to the power of u to the power of u, and then infinitely, and then plus, and then this is, let's see, u, and then we have, well, this is e to the x, but u is equal to e to the negative x. So e to the x, I'm sorry, so technically u is equal to e to the negative x, which means that it's 1 over e to the x. So then e to the x is equal to 1 over u. Okay, so that's what's going on. So this is u to the power of 1 over u, and then e to the negative x, which is from our du. So this is our integral. Okay. What now? What do we do here? Right. This is I don't get it. Right. What do we do from here? So yeah, this looks weird. This looks non-elementary. I don't understand what can I do here. So this is very sneaky. It's very hard to see. I don't think anyone would notice this, but Olympiads, or I don't know. But notice that okay, so I think it's easier if I go like this. We have a function where it's infinitely going off, right, to the exponentials. So because it's y equals x to the power of x to the power of, and then it just goes on infinitely, technically this whole part is the same thing as this whole part. It's the same thing as this whole part, right? So what that means is that y is equal to x to the power of y, Okay, it's an infinite function. Technically, it's an infinite function. So, okay. So why are we doing this? Well, the reason why I want to do this is because what if these are inverse of each other? Now, that seems crazy, and that don't look like they're inverse of each other. But look at this, right? Y is equal to x to the power of y. Then y 1 over y is equal to x. They are. They are inverse. They are inverse to each other. And it don't look like it, but they are inverse of each other. So this means that they are inverses. So okay, so what do we do with that? If you remember our the inverse sum, right? If we ever have f of x plus, actually, it would be a to b, f of a, f of b, right? Inverse, okay? Then this is equal b times f of b minus a times f of a. So this is the inverse sum formula here. Now, so we gotta make sure if this is also 0 to 1, right? So will it actually work? Well, x to the power of x to the power of x to the power or whatever, right? So using the same formula, right? We need to make sure that f of a, f of b, so we need to make sure that these two are equal because apparently we have this 0 to 1, right? But we have to make sure that this is true. If this is not true, then we have to alternate this function or u sub it or whatever in order to make the bounds be like this this formula. So, okay, so we have the function here, right? We plug in 1, it's definitely going to be equal to 1, so that's good. So b is equal to f of b, but we need a equal to f of a, right? 0 to the power of 0 to the power of 0 and whatever. What the hell do we do here? Right, this is indeterminate. So that's kind of tricky. So x, well, technically we're going from 0 to 1, so we're going at the positive side. So this is just to make sure. I don't want to cause any controversy just for my laziness. So here we have this, it goes off to infinity, right? And then what now? Okay, so x to the power of y. Right, we get the limit e to the y ln of x. And then but then we have to derive y. What is this, implicit differentiation? Oh shit, no way. Is that what I have to do? Implicit differentiation? Okay. Well, okay, this got very serious. Oh shit. So let's do implicit. Oh shit. Let's do logarithmic differentiation. Let me put this at the side here. So ln of y is equal to y ln of x Then we get y prime over y. Then we get y prime of ln of x plus y 1 over x. I'll just do y over x. Okay. Then we have y prime equal to y over x. This is what? 1 over 1 over y minus ln of x. So that's technically what we have. So I just take one side, factor out y prime, and divide it. Okay. Well, we have y square. So this is y prime. Okay. Well, if that's what I have to apply L'Hopital's rule, I guess. Well, I honestly don't want to. Oh, but then it would be 1 over y. Yo, this is nasty. Okay, well, in that case, we have ln of x, 1 over y, 1 over x. This is like negative. Oh god, I have to do this properly. 1 over x, negative y square, y prime, right? So then we get y squared over x, y prime, negative, right? And then the y prime is y squared here. So what we have is e to the limit of x approaching to 0, the right side. And then we have negative, let's see, the y squared cancels out. We get x minus y ln of x over x. And then this becomes, I'm going to need more room. Okay. Wow. I didn't think I would experience this. It's a very, very wild experience. Y ln of x over x minus 1. Okay. 0, 1 over x, 0, infinity. No. Ln of x over x. That is a problem. This gets absorbed. Oh, no. No fucking way. Did I put myself in the recursive? So this x can get absorbed because y, remember that y is equal to infinitely, right? And then x gets absorbed into y. And so we're literally back to like y ln of x. Except that this time we have a minus 1. And then, so what's going to happen is if we keep doing L'Hopital's rule here, we're literally gonna get I cannot believe this. Please make a video if there's a better way to do this. But essentially what's gonna happen is we're gonna get -1, do another L'Hopital here, -1, -1, -1, -1, -1, -1, and then we end up with so the limit equals to e to the power of -1, -1, -1, -1, -1, and then this becomes this, and it equals to 0. So technically this limit, and then infinitely, surprisingly does equal to 0, recursively. So then in that case, this does work. This does satisfy the inverse sum formula. Okay. Then that concludes the answer, 1 times 1 minus 0 times 0. So the answer is 1. Oh, good grief. I don't know if my limit answer was valid, so if you have a better explanation, please make a video. I would like to watch.